Good afternoon, everyone, and thank you for joining the first session of this afternoon for the FED4SAE Innovation Club. So we're going to have two sessions this afternoon. The first one will be a little bit technical. We will talk about an example of success stories of FED4SAE, which is about time verification, and we will talk more specifically about the platform Thales, which was one of the building blocks which was made available in the frame of FED4SAE and for the SME to develop business on top of that, and that received a premium support from Thales. So I'm Régis Samla, I'm CTO of Blue Morpho, and I'm going to be your host for this afternoon. You can contact me here this is my contact details. This webinar is recorded. It will be made available on the Blue Morpho YouTube channel, and of course you can contact me if you need on the app, on the FED4SAE app this afternoon. So this webinar is in fact the third in a series of three. There was first the Intel's Movidius platform, where we had some testimony of startups using the Movidius platform. Again, this afternoon, we're going to have another session where Finian Rogers is going to introduce us to two examples, two very specific examples. We also had a second webinar dedicated to ST microelectronics, the platform which was made available, the STM32, and also some great stories and great usage of this technology. These two webinars have been recorded and are available from our YouTube channel. And now we're going to talk about this is the third and last webinar of the series about the Thales platform. So I'm really pleased this afternoon to welcome Laurent Rioux. Laurent, you are a research thematic leader on timing critical system at Thales Research and Technology. So good afternoon, Laurent.
Good afternoon, Régis. Hello, everyone.
Yeah, thank you. And I'm also very pleased to welcome Mr. Adel Guthrie. You are CEO of Link Software, and you have been a sub-grantee of FED4SAE.
Good afternoon, everybody.
And good afternoon, Adel.
Thank
okay,
you,
so I'm going to give you a few words about FED4SAE. Only 2 slides. We talked about it this morning, but this is a quick reminder. You can see here the consortium of 13 partners among 10 countries, involving 8 research and technology centers and 5 industrial players. We are the only SME involved in the consortium. So one SME, this is Blue Morpho. The total budget was 7.6 million, and the EC contribution was close to 7. We ran 3 open calls, and 75% of that funding was dedicated for the cascade funding, for the funding for third party. So most of that budget went to the support of SMEs, and the rest was for the operation of the organization. We had 3 open calls. We started in 2017, second one in May 2018, and in December 2018. We had a total of 32 granted projects among 13 countries, and we distributed 1.8 million of cascade funding. So before we go into the technical presentation, I have a few questions for our audience, because I would like to know a little bit more about you. And first of all, I would like to know if you are familiar with the Eclipse Foundation and the Time4SAE tool, the framework, Time4SAE framework. So I will give you a few seconds to apply. And if you don't know anything about the Eclipse Foundation, that's great. In fact, that's great, because this will be a great opportunity for you to know a little bit more. And I give you a couple of seconds so that everybody has voted. Okay, so thank you very much for your reply. And I want to ask you a second question. So do you consider that time verification is very important for you? I would like to understand is you consider time verification in your design. Is it important? It might be interesting, you're not sure. Or at this stage, at the moment, you don't consider it. So that would be also helpful. And I see that in the audience today, we have majority of people who would like to know more about that, because we have people consider that it might be interesting for them. They need to know more. They need to understand a bit more of what is time verification and how it can contribute. So thank you very much. That is very helpful. And we know that we have an audience who wants to know more about time forces. So this is the opportunity that we're going to give you today with, so Laurent. Laurent, you are again research thematic leader on timing critical systems at Thales Research and Technology. And we're going to, I'm going to give you the control of the keyboard so that you can start your presentation. I have to switch to your slide deck. And Laurent, the floor is yours. Laurent, can you hear me? Can you see
I don't
the screen?
see slides.
You don't see the slide. I'm sorry. Yeah, you should see it now.
It's better. Hello, everyone, again. So I will present you the Time Forces platform. This platform has been initiated by Thales based on this need to verify real-time performance of their complex embedded systems. So to understand a bit about performance, I would like to mention here, I more speak about scheduling. When an application needs to be scheduling on the computing platform, they need to access to different resources, and the resources have to be scheduled to be sure there is no conflict about this access. And typically, when you do real-time embedded systems, the response time of your system is a key constraint, and a constraint that you must satisfy in major cases when you have certification aspect for your systems. You have also some other performance like resources dimensioning, like buffers, memory size, and energy consumptions are often additional constraints that you need to verify and provide for your system to your customers. So typically, you have an objective is to provide correct timing performance behaviors of your real-time system you want to deliver to your customers. For that, the solution that Thales promote and also the Time Forces promote is to apply early and iterative performance verification and validations to avoid costly performance failure detected after implementation and integrations. So typically, we encourage people very early in the design phase to verify its architectures, could be system architecture or software architecture, to verify the performance, typically the response time of the systems, and also to evaluate the various decisions that can be taken during the design phases. For example, if you want to split a function in 3 functions, so you can see what happened in terms of scheduling and then what happened in terms of performance at the end. You can also use this approach to fix and identify budget for your various functions. So during your implementation, you can verify that your function you have implemented meet the requirement you have already defined in your design phases. So to achieve that, you need to bring well-known technical verification, performance verification techniques, typically mathematical verification inside your design tools. And this is not an easy task. That's why Time Forces was born. The idea is to make a bridge between your design environment and the techniques available in a scientific way to verify and validate your performance during your process. So typically, of course, in the real world, you have a lot of software or system design tools used by architects, and these people are in their world and they design their system with their own process. And that's one side. And up another side, you have also available on the market on different area already performance verification tool existing, and some are open source, some are commercials. And the idea, of course, will be to connect each other these tools, but the problem is you are not able to do it very easily. Why? Mainly because the semantics use of different words are totally different. For example, in performance verification tools, you will speak about a CPU, about a task, about period. Things are not necessarily available in the software design tools. In the tool, we speak about threads, runnable in automotive. You will use also other terms. And moreover, on that, you have also different communications mechanisms in the design, which are not available inside the verification tools. Typically, verification tools suppose that all tasks communicate to another task at the end of the execution, which is very rare in your design. So there is a need to solve these semantic gaps. And also the architect would like to stay in this design environment and don't want to manage the complexity of verification tools. So that's why we have developed the Thales. So Thales is first able to extend your design tools by adding information about execution time, periodicity, every specific information related to retime. And then from that, you are able to generate and produce a design model in Thales. Then automatically Thales will do the semantic adaptation for your verification, performance verification models, and then automatically inject in the selected tool you have selected for your performance verifications. Once the computations of your performance is done, the result is returned back to Thales. Thales do apply again the transformation back to the design environment, and then the architect can see the result of the performance at this stage. And you can apply this process all along your design, from very high-level abstraction like systems design to the very low level like software development phases. So today, Thales is available in totally open source. And the idea to put it in open source is to help people to apply more systematically performance verification during the design phases at very low cost. That's the idea, and to share the experience and the code, typically. Thank you for your attention.
Thank you very much. I'm going now to switch to the other presentation, and we're going to move to the next speaker. We will take your questions at the end of the two presentations. So if I'm talking here to the audience, if you have further questions for the speakers, you can shoot them right now into the question box. You have that interface available for you. So next speaker for you today is Mr. Aydel Gasri. You are CEO of Link Software. And I'm going to, you have now the control of the screen. Floor is yours.
Okay. Hi, everybody. I start with the overview of my presentation today. I will make a brief company presentation, and then I will present the experiment, starting from the issues, then the objectives of this experiment, of this project. Then I will present the product itself, Runtime Architect Tool Suite, and I will end with some conclusions. So our company, Link Software, is a Tunisian company. We are developing innovative software packages and tools. Link Software was created in 2002. We employ today 14 multilingual people, among them 10 engineers. And our 219 turnover was around 50K. Our products and service portfolio consists on real-time production monitoring and quality control software packages for manufacturing, and performance engineering tools for providers of embedded real-time systems, as well as implementation and training services around our software offer. Our customers are mainly in Tunisia, France, Belgium, and other European countries. Today, we offer a complete suite of integration tools, helping system architects, developers, and test engineers of real-time embedded systems. So real-time systems are increasingly involved in many embedded systems, such as in avionics, in automotive, aerospace, railway, medical devices, etc. The correctness of these systems depends not only on the logical result of the computation, but also on the physical instant at which the result is produced. In hard real-time systems, the missed deadline may be catastrophic. Today, timing predictability is challenged by the high complexity of modern real-time systems, which is the consequence of the significant increase of the number of implemented software functions and the required computing and communication resources. Model-driven technologies are best suited to deal with such systems. However, there is a lack of solution reflecting the connection between the model and the real system behavior. Do the implemented system at runtime will behave as designed? The timing behavior at runtime has to be matched with the design in order to identify the timing failure in design and deviation from the real-time requirements. The objectives of the system are: give system architects the tools to verify if timing requirements are met in the system execution or communication, and identify at early stage potential timing bottlenecks. Help architects or test engineers understand the system timing behavior based on numerical and graphical statistics for the system execution or communication. Give the architect the opportunity to perform consistency check between runtime and models to validate timing-related assumptions taken at the design phase. Make possible the correcting of timing errors and exploring of design alternatives at the design phase based on the system runtime behavior before investing any time and efforts in implementing and testing. And finally, provide test and integration engineers the right tools to better analyze the missing temporal system behavior, and in the same time, contribute to better communication between system architects and test engineers. The Runtime Architect Tool Suite. With Runtime Architect, Link Software provides a complete set of solutions for performance design modeling, runtime traces analysis, and timing verification. Runtime Architect encapsulates the TimeForces platform in order to ease its integration in any runtime, design, or timing verification environment. It is composed of 3 modules: to parse the runtime properties, to graphically illustrate runtime traces and edit them, and explore design alternatives. By relying on the TimeForces design model and the TimeForces trace model, Runtime Architect benefits automatically from current and future connections to TimeForces of design tools, scheduling, analysis, and simulation tools, as well as tracing tools. Runtime Architect relies on the interaction of 3 modules that complement each other. Runtime Parser, to parse the runtime properties. Runtime Trace Editor, to graphically illustrate and edit the runtime traces. And Runtime Designer, to explore design alternatives. Runtime Designer interacts with the Runtime Trace Editor to rebuild the edited trace. After validation, Runtime Designer injects the results back in the TimeForces design model. So, the parser. The runtime traces in TimeForces trace model are parsed with the Runtime Parser module. The results of the parsing provide valuable feedbacks on system execution. This includes various numerical and graphical statistics for several timing properties, as well as the identification of performance bottlenecks or timing errors encountered in the traces, such as deadline misses or buffer overloads. The parsing results are displayed using the charts component of our tool Timing Graphics. Today, Link Software proposed to its customer through its product Timing Graphics one of the most powerful and advanced trace viewer for system execution or communication on the market. Timing Graphics includes add-ons that are specific to several industry domains, such as avionics, automotive, industrial process control, etc. The trace viewer can be used in standalone mode by the architect to monitor runtime traces, understand the system timing behavior, and identify performance bottlenecks. It can also be connected to any analysis or simulation tool to display the computed or simulated scheduling performance results. Runtime Architect now offers the possibility to start from runtime traces and then change the system configuration virtually to easily predict the performance impact of modifying timing properties of tasks. The graphical representation of the computed scenarios can be edited using the Runtime Editor module. The objective is exploring design alternative based on the system runtime behavior before investing any time and efforts in implementing and testing. The editor permits, for example, to select any graphical component in the display trace and modify its timing characteristics, such as increasing or decreasing the duration of function execution. Scenarios like, okay, my system runs well. What happens if the execution of a specific function takes longer? Can be answered thanks to Runtime Architect. The Runtime Designer module allows virtually searching for critical execution scenario for system performance, correcting timing errors, if any, and exploring design alternatives. For this purpose, Runtime Designer interacts with the Runtime Trace Editor as well as the TimeForces system design model to interpret the addition of the runtime traces. Based on that interpretation, it recomputes the runtime trace. For example, an increased execution duration of a given function decided in runtime trace editor make runtime designer rebuild the whole runtime trace, taking in consideration the task priorities as defined in the Time4SAE design model. Once an explored correction or design alternative is validated and the decision is made to integrate it, runtime designer injects the results back in Time4SAE. With SimTime, Link software provides a tool to determine safe and precise timing bounds based on Time4SAE models. The full potential of SimTime is obtained in combination with the Link software tools, timing graphics, and runtime architect. The seamless interfaces between the three tools offers capabilities of displaying and editing of runtime traces, enabling developers and integrators to debug and verify their software and validate their timing models. The rate application experiment permit to system architects, developers, and test engineers through the runtime architect tool suite, linking models with the system runtime aspects. This will allow setting up a continuous performance engineering cycles between design and runtime, ensuring the quality of the running system while reducing the design and development efforts and costs. Thank you for your attention.
Thank you very much. Thank you very much for your presentation. So I'm going now to move to the Q&A session. So I would like now to invite all the participants of this webinar to share their questions. You have a dedicated chat box for that. Okay, so maybe I will start with the questions. So, Laurent, I will start with you with a few questions about the Time4SAE tool. So this is something which was initially developed by Thales internally, right?
Yes, you're right.
Yeah. So, and this tool is currently deployed in Thales?
Yes, today we have deployed this tool in 5 divisions. And the biggest division where it's used in different projects is mainly Thales Avionics, which have a lot of criticality inside the systems. We have also deployed this tool for aerospace, typically Rafale plane for its equipment. We have also deployed these Time4SAE in Thales Ania Space for validation of the software on board software.
Okay, very good. I see that we have someone in the audience who raised a hand. So, Greg, I'm going to unmute you so that you can ask your question. So now, hello, Greg, you can ask your question. Yeah.
All right. So it's a question for Lauren. Hi. Do you know if those procedures you just mentioned are being integrated into or tested into virtual reality or augmented reality environment? Have you any scope to do so within Thales? Do you know that?
About virtual environment you speak about?
No, it's general engineering, let's say, tasks, move for engineering tasks to digitalize into virtual reality or stuff like that. And then in more details into procedures that you just presented.
Typically we use operating systems, so we don't use virtualization on top of processors. That is what you mean. And we are able to design with Time4SAE typically monocore applications and distributed applications. And we are able to manage very various of activation of tasks. So typically, we are only limited by the science of timing verifications. But today, we are able to manage very complex software with time forces, and we are able to validate a lot of tasks, even a chain of tasks. We are able to validate with time forces, and we have also used various of performance tools to verify the behavior and of our systems. I'm not sure I answer correctly, but
yeah, it was a good answer. Sure, the procedures for
Hi everyone, this is Thomas again.
For timing are not easily movable to virtual reality, but I was meaning the general engineering tasks like designing some parts and components and then testing the usability of them, of electronics, for example, a display or something like that.
Yeah, typically the approach we promote is we're starting from system engineering, and then you have your requirements. So you refine your requirement along the process. So you split your system and subsystem and task in a component and then in task. So you allocate it, budget it, and you verify always your requirement is met. And when you started development, you are able to measure the execution time of your different function and tasks. So you are able to integrate such value inside time forces, and then you are able to validate and verify your design is correct or your implementation also meet your budget or not.
All right, thanks.
Okay, thank you very much. Could you maybe, Greg, maybe you can explain a bit more about your application very quickly?
Yeah, we're a startup, a deep tech startup. We're introducing an input device that would allow you within virtual environment to design, engineer, and test the usability of objects by the use of your fingers. So it's highly detailed. And we have some early stage customers, large corporations like Siemens and Philips at the moment.
And you should
very exciting. Okay, thank you very much. That's a very interesting use case. And I hope you will have the possibility to further discuss with Laurent and maybe explore the possibility with Adam. And of course, if you can pitch your case in front of potential investors, that's also a great opportunity here. Laurent, let's talk a little bit more about time forces. I recently saw that Airbus, so it's an aeronautic application, Airbus has a platform which is open for artificial intelligence challenges. They publish, this is called AI Gym, and they publish some data sets for people to play with and to explore the possibility of using AI to solve a number of challenges. And one of the challenges that they have is, they call it the time series challenge, and they deliver a set of data. So of course, those data have been a little bit modified, have removed everything which is a little bit sensitive, so that people can play with. And they ask people to identify the anomalies in the time series. So do you think that there could be some connection between this kind of AI applications and time forces?
I'm not sure about AI, but at least time forces will be able to analyze the execution traces, and to compare them with requirements for the systems. So typically, you are able to define your requirements, and then time forces will help you to identify where the behaviors of your system, typically a plane or something like that, don't respect the requirements. And I think it could be also a question for Link software, because you have the trace editor, which is not available in time forces. So you are able also to point what's happened in the system and where and maybe identify the cause where there is some failures, timing failures of the systems. So typically, we are able to parse such information, and as we mentioned, like for linked software, I think Runtime Architect can also show some distributions. I think maybe Adele can also answer this point.
Yeah, Adele, do you want to comment on that?
Yes, with our tools, the possibility is given to parse the traces and to have valuable information with the tool, and then to play with these traces to make additions and.
Would you consider that your tool is in competition with AI, or is it something that could be, once you have identified the anomaly, you can work on it? Or do you consider that your tool could detect this kind of anomalies?
Please again the question.
Yeah, my question was, do you think that your tool is in competition with artificial intelligence to detect anomalies? Or do you think that once the anomaly has been detected with AI, your tool enters into play? So is it competing or complementary?
No, it's complementary. Once it is detected, the tool can be used to play different scenarios.
Okay, very good. So Laurent, again for you, maybe another question about the Eclipse Foundation. You mentioned that foundation. How does it work? Who is managing this foundation? Can you elaborate a little bit about the governance of this foundation?
This foundation is the same idea like Time4SAE somewhere. Is a way to share components for the design and the development of system of applications. Typically in Eclipse, you have UML tools, you have development environment for C++, for Java, you have various tools. So typically Eclipse is really focused to help people to develop their system and software in various activities. And typically that's why Time4SAE has been put inside this community, because it's also a way to promote our tools and to help people to develop real-time embedded systems. So Time4SAE follows the Eclipse license, of course, open source, and use also a lot of components available inside Eclipse, like EMF, which is the Eclipse modeling framework, and some other components like OBO designers for the graphic frameworks we're using.
Okay. Okay, so thank you very much. That's very interesting. So now, Adele, tell me a little bit more about this product. Tell me a little bit more, how did you get the idea? What was your motivation to launch this or to submit this project to FED4SAE?
Okay, providing our tools, timing graphics and sim times to our customers, we saw the need to a tool to do more with the runtime trace in terms of parsing the traces and editing the traces. And then came the FED4SAE call and the opportunity to work with Thales technology, Time4SAE. And now here we are.
Okay, I got it. And what was your experience in FED4SAE? How did it work? Can you explain to the audience how long did the project last? How many meetings did you have with Thales? Was it continuous support? Can you tell us a bit more about that?
Yes, the project starts actually mid-July 2019. And we started with the first meeting, and we did the requirements together with Thales. And we put some milestones that was important for us. First, we started to extend the time forces structures, and then we wrote an importer for the CTF trace format. The CTF trace format is a common format that is used by Linux systems. Then we had in Target a very important conference in Malta. So we prepared the alpha version of the runtime architect tool suite, and we presented that in Malta. Then we worked to finalize the product. Let's say May was the target to get to the beta version. Technology partner Thales provide us with a very interesting use case in avionics system, the flight management system. So we tested our tools, our modules on this use case itself, and the results were very good. It was planned to be present in different events in Europe, but this COVID situation has not let us do that. What we did is, together with Thales TRT, we give the opportunity to an engineer in the last stage of his studium, and then we tested the system in 19 other use cases. So that gives us the opportunity until end of August to really bring the system from a beta version to a version where we eliminated all the bugs. And the tests were all successful in the 19 supplementary use cases and the first use case provided by Thales.
Excellent. So that's a real deployment already, or is this are you still in beta phase?
No, the product is really now, let's say, in a release version, is not in a beta phase.
Okay, great. So for the moment today, you're open for business. You're looking for customers, and you will be happy to collaborate with anyone who's knocking at your door, right?
Yes, that's it.
Yeah. Okay. Okay. Thank you very much. So you explained us some concrete scenarios. So I don't see any more questions from the audience. So if you still have some questions, please type it into the chat box, or just raise your hands and we'll open the mic. Now maybe a last question for everyone. Do you want to get in touch with Thales, Link Software, or simply Blue Morpho? And of course, you can contact people directly with the app. As you know that we have this new tool in the frame of FED4SAE. And of course, you will have time for more networking in the afternoon. Okay, so I'll give you 5 more seconds to reply. And I close this poll. And I want
Regis?
Yes?
Yes, I would like maybe to complete my answer to Greg.
Yeah,
Because I got an idea. Just to mention, so we have also deployed the Time4SAE in Thales Optronic for image processing to optimize and to design the application, of course, but also to optimize the performance for image processing and detections inside the pictures.
Thank you.
Okay, so thank you very much. So again, thank you again. This is everything is recorded and will be made available on YouTube for you to look at that later.